Hello everyone, my name is Keith Martin Salas, and today we're going to talk about half-life problems. So as I mentioned, I'm Keith Martin Salas. I'm a grade 12 student and I'm currently taking up the IB program. So I'm a physics SL student and my physics teacher is Mr. Verdon. Shout out to Mr. Verdon. So okay, let's begin. So, of course, when solving half-life problems, we need to know the formula for half-life. This is A is equal to A sub O times E raised to ln 1 half times T divided by H, where A sub O is the original amount, A is the amount, T is the time, and H is the half-life. Okay, so let's get on to our first problem. Okay, this is our first problem. Iodine 131 has a half-life of 8 days. If the amount of iodine 131 in a sample is 8 grams, how much iodine 131 will remain after 32 days? Okay, so these are the given A sub O, which is the original amount, H is the half-life, T, which is the time, 32 days, and we are required to find the amount after the half-life occurs. So you have the formula A is equal to A sub O times E raised to ln 1 half times T over H. So all we have to do is to plug in these values here. So 8, we put it here. 8, we put it here. 32, we put it there. Then A, we're finding for it. So we just use our handy calculator. Then our final answer would be 0.5 grams. So half-life is that easy. Let's go to the second question. Okay. So the second question is that a piece of wood found in an ancient burial mound contains only half as much carbon-14 in as a piece of wood cut from a living tree growing nearby. The half-life for carbon-14 is 5,730 years. What is the approximate age of the ancient wood? So here we are given the number of the number of years for half-life, which is, let's see. Okay. The half-life is 5,730 years. Okay. Because the question stated that the original amount is 1 and the amount now is half the original amount, let's just say that the original amount was 1 gram and the amount now is 0.5 grams. So we are to find the age, right? The age of the wood right now. So again, we use the formula A is equal to A sub O times E raised to ln 1 half times T over H. So what we do is that we substitute the following values. So we got 0.5 is equal to 1 times E raised to ln 1 half times T all over 5,730, my bad. So what we first do is that we divide 1 by both sides, so it's equal to 0.5. Then we get the ln of both sides, which is equal to ln 0.5. Note that when we take the ln of both sides, one property of this one is that the powers can be dropped down here. So ln 0.5 is equal to ln 1/2. So we put it down here, times t all over 5,730. We put it down here. Then we get the ln of e. And we know that the ln of e is equal to 1. So using our calculator, the final answer would be 5,730 years. So, yeah. Okay, go on to the next question. We're at number 3. The isotope Pb-210 has a half-life of 22 years. What percentage of a pure Pb-210 sample prepared in April 1937 remains in April 2003? So, let's answer this right now. Here. We are given the half-life of 22 years, okay? Now the time is from April 1937 to April 2003. That is equal to 66 years. So just minus 2003. Subtract 1937 from 2003. So we know. So we have a half-life of 22 years, and the time it took is 66 years. So we know that there are 22 years in. There are three. My bad. There are 22 years in 66 years, because 3 times 22 is equal to 66. So, because we know that there are 22 years in 66 years, you have to multiply the half-life by 3 times. So, of course, half-life is equal to 0.5. So, 0.5 times 0.5 times 0.5 is equal to 0.125. We are required to find the percentage. Therefore, the percentage is 12.5%. Next number. So we are at number 4. Okay, for number 4, the half-life of protactinium-234 is 6.75 hours. How much of a given amount remains after 27.0 hours? So we have to find the fraction as stated here in the question. So we go to number 4 then. Here you go. Okay, so the half-life is 6.75 hours. Well, the time it took was 27.0 hours. So we know for a fact that there are 4 6.75 hours in 27 hours, because 4 times 6.75 is equal to 27 hours. Therefore, we have to get the half-life of the element 4 times. So you have to multiply 1/2 by itself for 4 times. So 1/2 times 1/2 times 1/2 times 1/2 is equal to 1/16. And because we are required to find it in fraction, 1/16 is the answer. Okay, next we have number 5. Okay, question for number 5 is that the half-life of plutonium-239 is 24,100 years. The original mass of the the original mass of the element is 100 grams. How much grams will remain after 96,400 years? Okay, so this is number 5. Let's go to number 5. Let's see. So the given is that the original amount is 100 grams. The time is equal to 96,400 years. The half-life is 24,100 years. and we are required to find the amount after 96,400 years. So using the formula, A is equal to A sub O times E raised to ln 1/2 times T all over H, you can get this one out. You can get this value. So what we do first is we plug in the, the variables. So 100, then we put the 96,400 here, then we put the 24,100 here, then using our calculator, the final answer would be 6.25 grams. Okay. Let's go to number 7. Here. How long would it take for 16 grams of Ra226 to break down? Oops, my bad. We're just in number 6. What is the half-life of an element if a 500-gram sample decays to 62.5 grams in 639,000 years? Okay, so number 6. Here we go. Number 6. Let me just cover the 5. Here we go. Okay, here we have number 6. So we are given that the original amount is 500 grams. The time is 63,900 years. And the amount after time is 62.5 grams. So we need to find the half-life of the element. Alright, element? Yes, of the element. So, the formula is still the same. A is equal to A sub O times E raised to ln 1/2 times T all over H. So what we do now is we plug in the values. So 500, we put it here. 62.5, we put it there. Then we get the 63,900. We put it here. So what we do again is we first divide 62.5 by 500. Then we get the ln of both sides. Again, if you get the ln of both sides, one property is that you can put down the power. So ln of 62.5 divided by 500 is equal to ln of 1/2 from here. Ln of 1/2, we put it down here. And we have 63,900 over H. We can put it down. We put it down here times ln E, and we know for a fact that ln E is equal to 1. So using our handy calculator, the answer would be 21,300 years.